In this video, we're going to take a look at two other parallelograms that we were not able to get to before the break. First one is called a rhombus. So a rhombus, it's a quadrilateral. It's got four sides where all four sides are congruent. So here's a classic example of a rhombus. Some people think of it as like a diamond. So if you have all four sides congruent, that actually passes one of our tests for parallelograms. That means that every rhombus is also a parallelogram. So all of the properties of parallelograms we saw before, like opposite sides parallel, opposite angles congruent, etc., those are all true for a rhombus as well. Now, whenever you draw those diagonals in, you can actually prove that you've got some congruent triangles using side, side, side. And that's going to give you two other theorems about a rhombus that you don't have for other parallelograms. So here, if you take a look at those triangles, if you do prove them all congruent by side, 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 because if it's a parallelogram, diagonals bisect each other, that's going to give you a bunch of angle pair relationships that are pretty useful. So first theorem, the diagonals are going to be perpendicular. And if you go back to that picture there, that's because those angles all where the diagonals meet would all have to be congruent. And since they're linear pairs, that make them all 90. And then all of your other angle pairs are going to be congruent. So the diagonals also bisect opposite angles. So there's your definition of a rhombus and two theorems. Also keep in mind, every rhombus is also a parallelogram. So all of those other things for parallelograms are also true for a rhombus. Also notice that the plural of rhombus, you could say rhombuses or rhombi. Both of those are acceptable. The last definition here is for a square. So a square is simply a regular quadrilateral. That means that all sides are congruent and all angles are congruent. You all know what squares look like. What that's going to tell us is all of the angles are going to be 90 degrees. And since all sides are congruent, that means that every square is a rhombus. And since all angles are congruent, that means every square is also a rectangle. And since both of those are parallelograms, every square is also a parallelogram. So a square has a whole bunch of properties that are really nice, things about all the angles. Diagonals are congruent, diagonals are perpendicular, diagonals bisect each other, diagonals bisect opposite angles. Every theorem about a rhombus, a rectangle, or any other parallelogram is also true for a square. And so we're going to be using those properties to find missing angles and missing lengths, things like Pythagorean theorem, etc. That should do it for squares and rhombuses.